In this video, we'll investigate the probability of combined events, and the examples we'll do today will deal with drawing cards from decks of cards, although the examples can be extended to problems with tables or other situations as well. And the types of problems we're going to look at are those like you see here. For example, perhaps we shuffle a deck of cards and we would like the probability of drawing an ace or a 10, or maybe we would like the probability of getting a red and a queen. And notice in these two examples, there are two connector words, or and. And those two words are very important here in communicating what we want to have with our probability. So before we dive into the mathematics, let's use some examples that cause us to think about those words. Let's say we go out to dinner together, and I say to the waiter, I'd like the chicken and the fish. And a few minutes pass, and my dinner arrives, and it is the fish. Am I happy? And hopefully you'll agree that I'm not happy in this situation. When I say the word and, that implies that I would like both things to happen. So I will only be happy if I get both chicken and fish. But how about if I go a different day? And this time I say to the waiter, I'd like the chicken or the fish. And I am presented with the fish. Am I happy? Well, in this situation, I am happy. I've received fish. That word or means I'd be happy if I were to receive chicken or fish, or even both. Both would be okay too. So those words and or are very valuable in helping communicate what's going on in the problem. So now let's extend this to probability. Let's take a look at one card being drawn from a shuffled deck. I would like the probability of a red and a face card. So right away, I can draw on my sample space of 52 cards. I'm only circling the cards that are both red and face cards. Notice I haven't circled the 5 of diamonds because even though the 5 of diamonds is a red card, it's not a face card. It doesn't qualify as both things. I also haven't circled the king of clubs. The king of clubs, although it is a face card, it is not red. We only want to circle those things which satisfy both conditions. And then we can simply count the number of successes, the number of favorable outcomes in our sample space here. And there's 6 of them. The probability of red and face card is 6 over 52. Here's another example. What's the probability of drawing a jack or an ace? Well, again, it's helpful to circle in the sample space. I've circled the jacks. I've circled the aces. And notice altogether it seems that there are 8 of them. But a quick definition here first. When two events do not overlap, we say that they are mutually exclusive. We have jacks over here. We have aces over here. They have nothing in common. They don't overlap. That term mutually exclusive won't be so important to your learning, but it's nice to tuck away. Mutually meaning between the two things, they exclude each other. So hopefully that term makes sense. And here we can simply count that altogether, the number of cards that are jacks or aces is 8. So the probability of jack or ace is 8 out of 52. One more example. What if I want the probability of jack or heart? So hopefully if you think ahead, you might already see the stickiness with this problem. I can circle the jacks. I can circle the hearts. And the one thing that didn't happen before is we have overlap between the two. We have a term for that. When two events do overlap, we say they are inclusive. They include each other. Now consider how might this affect how we consider the probability here. Let's see, I have 4 jacks, and I have 13 hearts, but I also have 1 overlap card. So you have to be careful here. If I were to take 4 and 13 and add that together, I would get 17. But that jack of hearts would get counted twice. So when we deal with overlap, we have to be careful of not double counting the overlap. And the way we're going to remedy that is we're going to subtract the overlap. So the probability of jack or heart is 4 plus 13 minus the 1 card that overlaps. So altogether, it'll be 16 out of 52. That's the probability we're looking for. And be careful here. The overlap isn't always going to be 1 card. You will see examples as you do problems where perhaps the overlap is more than 1 card. So just look out for that overlap. And in general, now we do have a formula for this situation. In general, for events A and B, if I want to find the probability of A or B, you take the probability of A plus the probability of B, and you subtract off the probability of A and B, which represents the overlap. For the problem we just did, this means the probability of jack or heart is the probability of jack plus the probability of heart minus the probability of jack and heart. And notice we could have done this problem easily without using the formula, and that's totally okay. But just respect that there is a formula we could use if the problems start to get a little stickier. And we do get the 16 out of 52.